Imagine walking onto a farm at sunrise and hearing almost nothing. No driver in the cab, no hands on the steering wheel. Yet a massive tractor moves across the field with incredible precision, following invisible paths as if someone were guiding it from the sky. Think about this, you're looking at one of the biggest changes in farming since the invention of the tractor itself. Today, we're going behind the scenes to discover how these intelligent machines are designed and built, and why their journey begins thousands of kilometers before they ever touch a field. Most people see an autonomous tractor as just another piece of farm equipment. But here's what nobody tells you. Inside that steel frame lives a network of computers, cameras, radar, sensors, hydraulic systems, electric wiring, and precision-machined components working together every second. Building one isn't simply manufacturing a tractor, it's combining heavy engineering with advanced robotics, software, and artificial intelligence. And before a single bolt is tightened, an incredible global supply chain has already gone to work. During the next few minutes, we'll follow this remarkable machine from the Earth's raw materials to the final assembly line. You'll see enormous steel mills, electronics factories, robotic welding cells, and testing grounds where every system must perform with astonishing accuracy. Along the way, we'll uncover surprising engineering secrets that most people never think about. And the first surprise begins deep beneath the Earth's surface. Every autonomous tractor starts with steel, and steel begins as iron ore. Large quantities of iron ore are mined in countries such as Australia and Brazil, where giant open-pit mines stretch farther than the eye can see. Massive haul trucks, some carrying hundreds of tons in a single load, transport the ore to processing facilities before it travels by rail and cargo ship to steel producers around the world. Imagine standing beside one of those trucks. You'd feel tiny next to a machine taller than many houses. Steel gives the tractor its strength, but strength alone isn't enough. Aluminum helps reduce weight in selected components, while copper carries electricity through kilometers of wiring hidden inside the machine. Copper commonly comes from major mining regions in countries including Chile, Peru, and the United States before it is refined into a highly conductive metal for electrical systems. Most people never see these cables, yet they quietly connect every sensor, motor, controller, and display. Now, imagine the tractor trying to drive itself without electronics. It couldn't. High-performance processors, cameras, GPS receivers, radar units, and other sensors rely on semiconductor chips manufactured through highly specialized global supply chains. These advanced electronic components are produced by different manufacturers around the world and then carefully integrated into agricultural equipment designed to operate in dust, vibration, rain, and intense heat. Rubber is another material you might overlook, yet it carries the entire machine across fields that can be muddy one season and rock-hard the next. Natural rubber is harvested from rubber trees grown in tropical regions, while synthetic rubber is produced using petrochemical processes. Tire manufacturers combine these materials with steel reinforcement to create enormous agricultural tires designed for traction, durability, and reduced soil compaction. Those tires don't just move the tractor. They help protect the land it works on. Glass, plastics, hydraulic hoses, lubricants, batteries, paints, and electronic connectors arrive from dozens of specialized suppliers before the first stage of assembly even begins. A single autonomous tractor may contain thousands of individual parts sourced from multiple countries. Coordinating their arrival requires careful planning, because one delayed component can slow an entire production line. It's a reminder that modern manufacturing depends not only on machines, but also on remarkable global teamwork. But here's something that often stays out of the spotlight. Mining, metal production, and global transportation all consume energy and can have environmental impacts. Many manufacturers are working to improve efficiency by increasing recycled material use, reducing emissions in production, and designing equipment that can operate more precisely in the field. The journey towards smarter farming begins long before the tractor reaches a farm. It starts with smarter manufacturing itself. So now every piece of raw material has completed an extraordinary journey across oceans, railways, highways, and factory gates. Steel waits beside precision electronics. Tires stand ready beside hydraulic systems. Thousands of separate parts are about to become one intelligent machine capable of working with remarkable accuracy. But what happens when those materials finally enter the factory? That's where raw resources transform into one of the most advanced tractors ever built. And what happens next surprises even experienced engineers. The moment the raw materials enter the factory, the pace changes completely. Every delivery is scanned, tracked, and checked before it reaches the production floor. Think about this. If even one critical component arrives with a defect, it can affect the reliability of the finished machine. That is why the manufacturing journey begins not with welding or assembly, but with inspection. Next comes the steel fabrication area, where towering sheets and beams are transformed into precision parts. Powerful laser cutters slice through thick steel with incredible accuracy, throwing showers of bright sparks across the workshop floor. Robotic bending machines shape each component according to digital designs, ensuring every frame section will fit together perfectly later in the process. The air hums with the sound of motors, hydraulics, and automated machinery working in perfect rhythm. Now the skeleton of the tractor begins to take shape. Industrial robots position massive frame sections with remarkable precision before robotic welding arms permanently join them together. Bright welding arcs flash like miniature lightning storms while the smell of heated steel fills the air. Every weld must be strong enough to handle years of vibration, rough terrain, and heavy agricultural work. After welding, the unfinished frame moves into surface preparation. Automated cleaning systems remove dust, oil, and tiny metal particles that could interfere with the protective coating. The chassis then receives corrosion-resistant primers followed by durable paint inside enclosed spray booths. When the freshly coated frame emerges under bright inspection lights, it already looks like a finished machine, even though the most advanced components have yet to arrive. Meanwhile, another team prepares the heart of the machine. Depending on the model, technicians install either a diesel engine or an electric drive system, along with the transmission, axles, and hydraulic pumps. Overhead cranes gently lower these heavy assemblies into the waiting chassis, while skilled workers guide every connection into place. It's a carefully coordinated operation where human experience and precision lifting equipment work side by side. But here's where an autonomous tractor separates itself from a conventional machine. Cameras, radar units, GPS antennas, wiring harnesses, electronic control modules, and powerful onboard computers are installed throughout the vehicle. Every connector must fit perfectly because these systems constantly exchange information while the tractor operates. Imagine thousands of electronic signals flowing through the machine every second, helping it understand exactly where it is and what surrounds it. The operator's cab comes together almost like the cockpit of a modern aircraft. Large digital displays, ergonomic controls, climate systems, suspension seats, and communication hardware are fitted with great care. Even though the tractor can operate autonomously under appropriate conditions, manufacturers still design the cab so an operator can comfortably supervise or manually control the machine whenever needed. Comfort and technology meet in one remarkably advanced workspace. As the assembly line moves forward, enormous agricultural tires meet their matching wheels before robotic equipment and technicians install them onto the finished chassis. The machine finally stands on its own, revealing its full size and presence for the first time. What began as piles of steel, electronics, rubber, and glass has become something that already looks ready for the field. But appearances can be deceiving because the most demanding stage is still ahead. Before any autonomous tractor leaves the factory, engineers load software, calibrate cameras and sensors, and verify that every electronic system communicates correctly. Even tiny alignment errors can affect how accurately the machine interprets its surroundings. That's why technicians carefully check every subsystem before moving the tractor to its final testing area. And this is where it gets truly extraordinary, because the next stage determines whether the machine earns the right to work in real fields or returns for more adjustments. The factory doors slide open, and the newly built autonomous tractor rolls into one of the most advanced testing areas in the entire facility. At first glance, it looks complete. But here's what nobody tells you. This machine hasn't earned the right to work in a field yet. Before it ever plants a single seed, every intelligent system must prove it can perform exactly as engineers intended. Next comes artificial intelligence. The tractor's onboard computers process information from multiple sensors at the same time, helping identify rows of crops, field boundaries, and potential obstacles. During development, these systems are trained and evaluated using large collections of agricultural data gathered under many different conditions. What happens next surprised even experienced engineers, because a machine that performs perfectly indoors may face entirely different challenges under bright sunlight, heavy dust, or sudden rain. That's why manufacturers move beyond laboratory testing and into realistic field simulations. Engineers place objects along test routes, vary lighting conditions, and evaluate how the tractor responds to changing terrain. Every successful decision builds confidence that the machine can operate safely within its intended design. Most people never think about this, but teaching a machine what not to do can be just as important as teaching it what to do. Quality control reaches far beyond software. Inspectors examine welds, painted surfaces, hydraulic connections, electrical wiring, and mechanical assemblies using specialized measuring equipment. Depending on the manufacturer, laser scanners and coordinate measuring systems help verify that critical parts remain within very small engineering tolerances. Even a tiny deviation can require additional inspection or adjustment before production continues. The tractor then faces durability testing designed to simulate years of demanding work. It may travel over rough tracks, uneven ground, and specially constructed obstacles while engineers monitor vibration, steering response, and structural performance. Hydraulic systems, suspension components, and electronic modules all experience repeated stress intended to reveal weaknesses before customers ever see the machine. Every unexpected noise becomes a clue worth investigating. Environmental testing adds another layer of complexity. Manufacturers evaluate how the tractor performs in hot weather, cold temperatures, rain, dust, and vibration because farms operate in every kind of climate. Sealed electronic housings, weather-resistant connectors, and carefully protected wiring help keep essential systems functioning when conditions become challenging. Imagine trusting a machine to work through long harvest days without missing a beat. With so much automation inside the factory, you might think robots do everything. But here's the surprise: experienced technicians still play an essential role. They notice subtle sounds, slight vibrations, or small visual details that automated systems may flag for closer review but cannot always interpret on their own. Human judgment remains one of the most valuable quality control tools in modern manufacturing. Finally, after countless inspections, software checks, and performance evaluations, the tractor receives approval for shipment. It stands quietly beneath bright factory lights, ready to begin a completely different journey across highways, railways, or oceans toward farms around the world. But our story doesn't end at the factory gates. In the next chapter, we'll discover how autonomous tractors are reshaping global agriculture, and the numbers behind this revolution are far more surprising than most people imagine. The journey doesn't end when an autonomous tractor leaves the factory. In many parts of the world, these machines are already helping farmers plant, spray, and cultivate fields with greater precision. While fully autonomous tractors are still a relatively small part of the global tractor market, interest continues to grow as manufacturers invest heavily in automation, connectivity, and precision agriculture. Imagine thousands of intelligent machines quietly working across fields, guided by satellites instead of steering wheels. Today, companies in North America, Europe, and Asia are leading the development of autonomous agricultural technology. Their engineers combine traditional mechanical engineering with artificial intelligence, machine vision, robotics, and cloud-based software. Instead of simply building larger machines, the focus has shifted toward building smarter ones. And this is where it gets truly extraordinary. Every new generation learns from the experience of the one before it. Agriculture itself has changed dramatically over the past 50 years. Farmers once relied almost entirely on manual steering, paper maps, and visual judgment. Today, many modern tractors can follow satellite-guided paths with remarkable accuracy, record field data, and communicate with farm management software. Autonomous operation builds on these existing technologies, extending precision even further while keeping farmers informed and in control.
Think about this.
The world's population continues to grow, yet the amount of available farmland does not increase at the same pace. According to agricultural experts, improving efficiency will play a key role in meeting future food demand. Technologies such as autonomous tractors, precision planting, and data-driven farming aim to help growers make better use of land, water, fertilizer, and fuel without relying on guesswork alone. Did you know that many of today's advanced tractors can already steer themselves along planned routes while an operator supervises the work? Did you know that cameras and sensors can help detect obstacles or monitor field conditions in real time? And did you know that some experimental farming systems are exploring coordinated fleets of autonomous machines working together? What once sounded like science fiction is steadily becoming part of modern agriculture. We've traveled from vast iron ore mines and advanced electronics factories to robotic assembly lines and intelligent testing facilities. Along the way, you've seen that an autonomous tractor is far more than steel and machinery. It's the result of decades of engineering, thousands of carefully manufactured parts, and countless hours of design, testing, and refinement. Every component has a purpose, and every innovation moves agriculture one step closer to a smarter future. As technology continues to evolve, the relationship between farmers and machines will evolve with it. The goal isn't simply replacing human effort, it's giving people better tools to grow food more efficiently and sustainably. Whether you're fascinated by engineering, agriculture, or robotics, one thing is certain: the next generation of farming is already taking shape, one intelligent machine at a time. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.